Little review, a numeral names a number. Numeral tokens are instances of numeral types. In the same way we can have one word type the, but numerous instances of it, numerous word tokens, we can have one numeral type, but many instances of that numeral type, numeral tokens. I used to teach Spanish, and once I taught the kids how to say the first, 20 numbers, everything was easy after that, because once you learned 30, 30, you just add and 1. 31, 32, 33. And then once you learn 40, 40, you just add 41, 42. In other words, there are some rules that you could set up, and as long as you learn that new one word, then the rest of them are easy. Of course, the problem comes when you have to learn that one new word. 30, 40, 50. But in Western Arabic numerals, once you learn the digits 0 through 9, really you can devise a set of rules to make up any new number that you want, right? You don't have to think, like in language, you don't have to think about, wait, what is billion, trillion, what is it, quadrillion? What do you say after that? When it comes to the numerals, all you have to do is have this set of rules, and then you can create all of them. With that in mind, let's see why Pollard is introducing this new numeral system. Again, he's got this super simple system of making numeral tokens, right? 1 tally, 2 tallies, 3 tallies. And we can set up a small set of rules to make a new numeral token from any numeral token that we've got. First, you start with a numeral token. Let's start with a specific numeral token, say 5 tally marks. And notice, I'm starting with a numeral token, right? This specific instance of 5 tally marks. Next, we add 1 tally mark. Now, Pollard uses all caps to call attention to the fact that he's going to use these next words in a very specific way. He says that the construction add 1 tally mark yields the result. So what we will call the result is the new numeral token that consists of all the original tally marks from that original token plus this new tally mark that we just put on there. Now, why be so specific? Well, you could get confused. Did we just create more than one numeral token? For example, the last tally mark of the original set of tally marks plus this new tally mark, right? Those are 2 tally marks. Isn't that a numeral token? Well, maybe not. We're not interested in that. We're calling it the result because what we really care about is all those original tally marks plus this new tally mark. That's the numeral token that we want. And whether there are more or not, who cares? Now, why are we creating such a system in the first place? Well, at the beginning of the video, I said what's great about numeral systems is that you can have some set of rules and create any numeral token from it. In Western Arabic numerals, the ones that we use in the United States, and in many places in the world, our rules look something like this. Start with 9 digits in order, 1, 2, 3, 4, 5, 6, 7, 8, 9. Next, we add a new digit, 0. But we also add, in a new place in front of that digit, the digit 1. And that makes 10. Now, to make the next numeral token, we have that 1 in the same place, and then we add the 1 behind it, a 1 and 2, a 1 and a 3, successively 1 through 9 to make 11 through 19. Next, instead of writing a 1 in that new place, we write a 2. And again, 2, 0, 2, 1, 2, 2, all the way to make 20 through 29, etc., etc. But think about Pollard's system. There's only one digit to it, the tally mark. So there's no fussing about what to put in a place. In each new place, the only choice you have is that one digit, the tally mark. And there's no order for them to go in because they're all just tally marks. They're all the same thing. So our rules consist of really one step to make a new numeral token. Add a new tally mark to the original tally marks. And that's much simpler than our set of rules. Now, before you go campaigning to try to get Pollard's system instituted over our Western Arabic, think about this. Pollard's system is really absolutely useless for all practical purposes. I mean, imagine writing the number 1 trillion. In the Western Arabic numerals, it would only take you about 5 seconds. In Pollard's system, it would take you 30,000 years. So why do it? Well, Pollard's about to show us how to build a system of arithmetic, starting with the rules of building new numeral tokens. But there's no need to start with complicated rules. We'll start with the simplest rules possible. Then, once we're done, he'll have proved that his project is possible. If you're really interested, you can go back and do that project with our Western Arabic rules, but you'll pretty much have gotten the gist of it by that point. Now, we're gonna have to talk about this a bunch in what follows, but I don't want to keep saying that blah blah is the result of adding blah blah to blah blah blah. So let's get a new symbol. Definition 1.2, upsilon of xy. Upsilon of xy, if and only if, numeral token y is the result of adding 1 tally mark to numeral token x. So now we have a new Greek symbol, upsilon, to go along with the last one, tau. And I suppose I should explain first why doing that little if and only if is a definition. Notice our whole object here is to say that that little upsilon just means the result. And we do that with the if and only if. What we're saying is whenever we say upsilon of xy is true, it's also true that numeral token y is the result of adding one tally mark to numeral token x. And also the reverse is true. If it's true that numeral token y is the result of adding one tally mark to numeral token x, then we'll say that upsilon of xy is also true. Now why not just say upsilon of xy just means numeral token y is the result of adding one tally mark to numeral token x? Good question. I think it's an attempt to avoid problems of semantics and philosophy of language in mathematics. There are debates about meaning, and we don't really want to get into them right now. What we're giving now is an extensional definition. Whenever we have all of one thing, we always have all of the other thing, and vice versa. Whenever we have upsilon xy, we always have numeral token y as the result of adding one tally mark to numeral token x, and vice versa. Unfortunately, this strategy of extensional definition has its problems as well. However, the problems of both these things really aren't problems for what we're doing right now. So although it's weird to see the if and only if, I personally just read it as saying, hey, whenever I write upsilon xy, here's what I mean. Numeral token y is the result of adding one tally mark to numeral token x. Now the only thing we've done thus far is to show how to make an unlimited number of new numeral tokens out of old ones. Although it seems obvious, we haven't explained how we're going to put them in order yet. Also, we haven't related their numeral types just yet. That comes next.